If anyone wants to check, I can write out the first 30 digits and then you can check against the web. Just in case. Okay, so my name is Dinah. As mentioned, you can find me on Twitter and GitHub at DinahShe. I'm Canadian. I grew up in a town, not a town, I grew up in a city called Toronto, the largest city in Canada. And I think I accidentally, illegally flew here. But one of the speakers tomorrow might tell you about how that ended up happening, so I'm not going to touch on it. I am an infrequent contributor to ActiveRecord as well as other parts of Ruby on Rails. But luckily for you, the part of ActiveRecord that we're going to be talking about today is a part that I'm quite familiar with. I'll say quite, not very, just in case someone calls me out on it. So we're going to be talking about eager loading, different options for loading associations, and specifically around performance. So if you were at RailsConf this past year, or if you've seen the videos because they're all published now, you may have seen DHH, the creator of Ruby on Rails' keynote, and one of the things that he talks about during his keynote is conceptual compression. Conceptual compression is basically the process of going from Lego to Duplo. If you're interested at all, I would say check out the talk. I'm not going to give it all away, but basically Lego is the really low-level stuff. So it's assembly, memory management, database administration. It's the kind of stuff that if you know really well, you can build a very highly customized system for your particular application and your particular needs. Duplo is the higher level stuff. It's running Rails new and getting a working web application. It's thinking in terms of your business logic alone and relying on tools that other people have built and proven to have worked. So the part that I really like about this discussion is he focused a lot on how conceptual compression lowers the barrier to entry to programming, and it allows more people to discover this wonderful world and everything that it can allow them to do, and I really love that. And that makes me really excited about contributing to things like ActiveRecord and Ruby on Rails. So during his talk about conceptual compression, DHH alludes a lot to ActiveRecord, and there's a really great reason for this, because ActiveRecord is really, really good at compressing everything you need to know about databases to build a web application. So just so I know what I'm working with, can I get a show of hands of who works with ActiveRecord? Okay, so this talk's gonna be good. Great, okay. But just in case, I'm gonna make sure that we start with a really strong foundation, so I'm gonna define ActiveRecord. ActiveRecord is an ORM. And an ORM, here's the Wikipedia definition. I read it and it didn't really make all that much sense to me, so I'm gonna point out some of the key bits and then we'll break it down a little bit. So it's a technique for converting data between incompatible type systems to create a virtual object database. So basically it's the interface between your database and your programming language, which might be Ruby, your business logic and all of that stuff. So ActiveRecord is the ORM that ships out of the box with Ruby on Rails, but it's also built to be a standalone module, so you can use it in a script if you really wanted to. You can use it with other types of frameworks. In particular, I've seen it used quite a bit with Sinatra. ActiveRecord is actually named after a programming pattern, not a principle. So it was first named by Martin Fowler in his book, Patterns of Enterprise Application Architecture, which just sounds riveting. So he defines it as, an active record is an object that wraps a row in a database table or view, encapsulates the database access, and adds domain logic on that data. Hopefully if you use ActiveRecord, that sounds really familiar to you because that's exactly what it does. And it does that through this class called ActiveRecord base that basically maps to a row in an underlying database table. And it's got functions on it like create and update, as well as properties that correspond to the table table columns. And that's basically that bit about encapsulating database access. And finally, when you're using ActiveRecord, your models will usually subclass ActiveRecord base, and that's what allows you to add domain logic on top of that data. So ActiveRecord is really great because 10 to 15 years ago, a lot of web developers wrote a lot of SQL queries on a daily basis. And now, if you're using an ORM like ActiveRecord or even any other ORM or some sort of framework, it's very likely that you don't have to write SQL queries on a daily basis. I've met a couple people here who enjoy that. Particularly not me. So I really like that ActiveRecord allows you to stay in the context of Ruby. You get to stay in your business logic. You don't have to think about other languages. You don't have to think about underlying tables that much necessarily. However, and that's really great because it means you're probably working a little bit faster. However, that means that sometimes when you think about a particular page load or an endpoint, you don't necessarily know how many queries are going to be run on that page load or on that endpoint. And that's where you can run into problems. Because you're so used to dealing with these objects as Ruby objects that you might forget that everything you do to these objects can result in some sort of a database query. So I'm sure a lot of you are familiar with the n+1 query problem, but I'm going to explain it anyways. So the n+1 query is one of those instances. It starts with some sort of association model. I'm going to use the very common example of post to comment, so something like a blogging application you can imagine. Post has many comments, and a comment belongs to a post. So I'm going to use the terminology that the post is the owner object, and the comment is the association or the associated object. If you're using Rails, this might be the code that you use to render those objects on a web page. So you would loop all over all of your posts and render all of the comments per post. And if you're not doing anything special in your controller, you're going to end up with this in your database logs. So at the top, we see that we're loading all of the posts from the database, and then per post, we're going to load the comments for that individual post. So we have one query for the posts, and say that returns n post objects, or n post rows. Then we're going to have n queries for all of the comments. 1 plus n equals n+1, and that's where the n+1 query gets its name. If you're using ActiveRecord without a Rails framework, or you're just not rendering views, if you have a Rails API, this is probably what it looks like to you. And actually looking at it from this view, it's pretty clear why this happens, because we see that in the scope where we use post to access the comments, so in this case, that's going to be within the each loop. The scope only contains one post object. So of course, when we go to fetch those comments, we're only going to fetch the comments for that one particular post. And this is what the logs would look like for that. So once again, the n+1 problem. So why is this bad? Well, because you can do this in fewer you can do this in fewer queries. So you don't need to be taxing your database this much just to get that information. If you Google this really quickly, the kind of accepted answer is to use includes. Includes is what ActiveRecord offers you so that as developers, we can tell ActiveRecord, we're going to load this some sort of owner object, but we're going to be using the associated object really shortly after that. So while you're getting the owner, just go ahead and get the association as well. Go fetch all of those things all together. This is what it looks like when we use includes, post.includes comments. There's actually a lot of there's a lot of flexibility around this API. You can pass in a list of associations, you can pass in nested associations via hashes, so you can take a look at that. And all of a sudden, our logs look way better, because instead of n+1 queries, we just get the one query for the posts, and then using the set of IDs that's returned from that first query, we're going to load all of the comments associated to those post IDs. If you're paying really close attention, you might notice that this timestamp is actually substantially slower. That's just because the previous logs were kind of concatenated, or not concatenated, shortened, because you didn't need to see all n of them. But trust me, this is faster. This is usually faster. And let's try to understand how this works under the hood. What does ActiveRecord do to allow us to be able to make this call, and for the SQL queries to change the way that they did? There's a few concepts at play. One of them is chaining. The reason that we can make ActiveRecord queries like this is because of chaining. And chaining is not specific to ActiveRecord. A lot of frameworks, libraries, programs do this. So ActiveRecord offers a lot of query methods. There's where, there's limit. offset, join, includes, things like that. And you're able to just chain them onto the end of a query. You can keep chaining, I don't know, until the cows come home. And the reason that's possible is because at the end of each chained query method, you get a returned instance of a relation. And in fact, it's a new instance of a relation. So when we're working with a relation, that means that we're now able to continue chaining. We're able to keep making these query methods. So I just picked a shorter query method to show this on. So this is the limit query method. This is just pulled straight out of ActiveRecord's code. And you can see that it's a one-liner. The first thing that it does is spawn. And spawn is actually a wrapper around just the method clone in Ruby. So it's going to use the copy constructor of the relation class and create a cloned relation. So it's a new instance, but it looks, or it should be, basically the same. And then it's going to make some sort of mutations on that. In this case, it's going to make that mutation through the .limit bang class. And it's not super important right now what that mutation is, but it is important to realize that nothing's really happening here. No queries are being executed, but we are returning an instance of a relation. The second really important concept is that relations execute queries lazily. That's a pretty information-dense 4 words, so let's define each piece. A relation is one of those really important concepts in ActiveRecord that you likely deal with quite a bit. So earlier I said that ActiveRecord base basically maps to a single row in a database table. A relation is a closer mapping to a query in SQL, for instance. So the whole point of having a relation is to build these queries and then to execute them. Relations in ActiveRecord execute these queries lazily. And that means that when you're building that relation, nothing's actually happening. And the only time that it's going to execute that query is when you call .each or .toA, when you want to iterate over the objects that are returned by that query or convert them into a Ruby array. And that's actually a pretty strong design choice by ActiveRecord, but it affords a lot of the things that we're going to be talking about soon. So let's trace the 2 lines of code that we've been looking at. The first line is just post.includes comments. And the implementation of includes is pretty similar to limit. It's just going to check the arguments, see that you have actually passed in some valid parameters, some valid associations, and then it's going to spawn a new instance of relation and then call a mutation. The .includes bang method, the first 2, whatever, we're not really going to talk about those first 2 lines, but basically what it does is take the arguments that you passed in and set them on the relation under includes values. So these are instance variables on that particular relation instance. And then it's going to return itself, a reference to itself. Again, notice that no queries are being executed. It's not until we get to the second line when we call .each on this relation instance that the query is actually going to be executed, because we're saying we want to iterate over all of the objects, all of the post objects returned by this query. And like we saw earlier, this is going to result in those 2 queries. The first is getting all of the posts, and the second is getting all of the comments associated to the posts returned by that first query. That's great, we understand that. But that's not really the whole story behind includes. This is actually just one of the ways that includes uses queries to load your associations. The second way is by using 1 query instead of 2, and this strategy uses a left outer join. Now the left outer join basically takes the owner table and whatever the association is, it joins them together and then filters them. The problem with the left outer join is that it's one of the most expensive operations you can execute in a SQL query. So we want to avoid this as much as possible. It's usually a safe bet that the 2 query strategy is going to be a little bit faster than the left outer join strategy. So why is this here in the first place? Why does ActiveRecord do this? And how does ActiveRecord figure out which strategy to give you? So it defaults to that 2 query strategy because that's usually the faster strategy. But sometimes you actually need that left outer join. So the case where you need it is if somewhere in the rest of your query you're referencing the associated table. So in this query we can see in the where clause that the clause itself references the comments table. So it doesn't really make sense for us to execute two queries here. We have to at some point do this cross product essentially to make sure that we join the tables together and then filter out based on what we need. This is the only instance essentially that ActiveRecord is going to give you that left outer join. How does it figure out on the fly how to do this? Well, it looks at the rest of the query, it looks at the instance variables that tells it what the rest of the query is supposed to do, and if it sees that reference to the associated table, it's going to use the left outer join. So, if for some reason you want to tell ActiveRecord which strategy you want, and I don't usually recommend this, I think it's usually the best bet to just use includes. If anything, if nothing else, it means that you don't have to think about which method to use. You can just trust that ActiveRecord is going to make the best decision for you. But if for some reason you want to tell which strategy to use, there are a couple of options for that. And one of the reasons that I can think to do this is mainly for code comprehension. If you want to be able to look at a line of code and know exactly what SQL query is running in the background, then these options might be helpful. The first is preload, and this is basically going to give you that two-strategy solution every single time. The implementation looks really similar. It's going to check your arguments and then spawn and call this preload method, where the preload method just takes your arguments and adds it to the preload values instance variable on the new instance of the relation. The second method is eagerload, and this is going to give you that left outer join strategy. So when you call eagerload, ActiveRecord is not going to check for you at runtime whether or not it's necessary to perform this left outer join. It's basically going to assume that if you've called eagerload, you probably know what you're doing. We're just going to left outer join this for you. Again, the implementation is really, really similar. It just spawns and then sets these values that you've passed in as eagerload values. This is the code that actually executes the query. It's a lot harder to read at a glance. It's not really important that we understand every line and what's happening here. But the two pieces that I do want to point out are how this bit of code interacts with those eagerload values, preload values, and includes values. So the first thing that it needs to check is whether or not any eager loading needs to be done. Because eager loads actually change the original query. They change the query that we run to get those owner records. So we want to make sure we know what we're doing. That eagerload helper method, all it's basically doing is saying, are there any eagerload values on this particular instance of relation? And those would have been set if you had called eagerload directly. Or are there any includes values that are referenced by the rest of the query? If so, we're going to go and do that left outer join. After we load the owner records, so after that, the main block of this function, is when we go and preload associations. So note that they're not mutually exclusive. If you wanted to, on a relation, you could totally preload and eager load associations at the same time, or you could do this all through includes instead of calling the underlying functions. And you probably wouldn't want to call preload and eager load for the same association, but I can certainly see a use case for this if your associations were kind of unique and you wanted to interact with them differently. So the preload associations is going to do a similar check. Are there any preload values? So did the developer specifically want something preloaded? And if so, or if not, it's going to then go and look at the includes values. Were there any associations that we haven't loaded yet that don't get referenced by the rest of the query? And it's going to run out this class called preloader, which I'm not going to get too much into, but basically it's going to execute one or more queries to preload all those associations. And that's basically how ActiveRecord loads associations. It's not that complex if you take a look at it at this level. And N+1 queries are ideally not too complex to solve if you're able to understand the concept of preloading, eager loading, how and when to use each. But they're usually way harder to spot in production. They're not usually two-liners right next to each other, where it's pretty easy for us to kind of look at it and say that's probably going to result in a problem performance-wise at the database level. So, of course, as I think a few other speakers have already mentioned, but definitely around performance issues, you want to rely on your profiling and benchmarking tools to see where the actual bottlenecks are, to see if you actually have an N+1 query problem. But another great tool that I've heard multiple times but haven't personally used is the bullet gem. And this helps you find N+1 queries if you turn it on in development. It also helps you find any associations that you've either loaded, preloaded, but aren't actually using, because you can just get rid of those really quickly. Okay, so we've said that N+1 queries are bad, and we know that includes either load, preload, that these are solutions to N+1 queries. So should we always use includes? Well, it depends. Of course it depends. Every programming problem, really. One of the problems that's perhaps not discussed a lot with includes around N+1 queries is memory. So for this presentation, I made a little sample app to kind of pull code snippets and logs and things like that, and I seeded my database with 10 post objects and 1,000 comments per post. So that's 10,000 objects being loaded into memory if I call post.includes comments. That's not really a big deal if you're not concerned about that in your particular case. So if you have really sparse associations, if for example every post only has 1 or 2 comments, it's not really that big of a problem. Or if your associated class is really small, it's also not that big of a concern. But if everyone is leaving essay-long comments and you have 1,000 comments per post, this quickly balloons to be quite a big memory issue. So how can we fix both? Well, sometimes there's no way around it. If your use case was that view that I had showed earlier, where you actually want to render every single comment for every single post, then you're going to need to load them into memory. There's not really a way around it. But because we know that this memory is a little bit of an issue, we want to make sure that if we're going to call includes, if we're going to incur this debt, then it's actually worth it. So here's an example of a case where you don't need includes. If you wanted to just output the number of comments, it's pretty clear that we don't need the entire object. We just need a count. So if I was to run this view, and I don't do anything special in the controller, I'm not using includes or any of the other types of includes, we actually already get a tiny bit of improvement. If you remember, this is what our old database log looked like, where we have the N+1 query and every kind of nested query is a select comments. But when we change to post.comments.count, ActiveRecord figures out for us that we're not actually really looking for the object. We're looking for a number of objects. So instead of running select comments, which is going to load that entire object, it's just going to run a select count query. And just by doing that, we've already eliminated the memory bloat issue, because we're no longer loading 10,000 objects into memory. We're just working with these numbers. And it also helps that select count queries are quite a bit faster than your typical select comment query. So without doing anything, we fixed the memory bloat issue. Hooray, that was easy. But we still have that N+1 issue. So is there a way that we can solve both problems? Fortunately, this actually comes up so often where you are looking for the number of a certain type of association that there is a feature for this. And it's called the counter cache. So this is how you turn it on. You would go into the associated class and just say counter cache true. And it works pretty much the way that it sounds. It keeps a cache of the count of the associated model, and it does this by actually writing that value to a column on the owner's table. So in this case, it would be a column on the post table. And by convention, it's going to expect that column to be called comments count. But you can always overload that if you want. Take a look at the documentation if you are interested. So this is kind of the first piece of adding counter caches to your application. The second piece is running this migration. Like I said, it requires that column, so you need to add this comments count column into your post table. And of course, we're going to default it to 0, and it's an integer type. Now, that's not really the entirety of the migration, and to understand the next bit, we should know how exactly this works. So every single time that we create or destroy a comment object, instead of just doing that one create or destroy query, it's also going to run this update query. So this update just goes and adds 1 or subtracts 1 to whatever value is sitting in comments count on the owner's the owner class's table. So that means that if you're not running this migration on an empty application or on a new application, which most of the time you're probably not building apps from scratch, that you also need to do this backfill. So the second part of this migration is basically doing that. It's going to do this job one time. It's just going to count all of the comments associated to this particular post and then write that value into the comments count column. Okay, so what does the log look like if we're using the comment count? And notice that this does mean that you need to change the line of code in your view to actually reference the comments count. Now, instead of n+1 queries, or instead of even 2 queries, we just have the one query. We're just going to select posts, and with those posts, we're pulling in the comments count from the database. So, great, we've solved the problem. We have just one query, and ideally this is going to be pretty fast, especially compared to that n+1 query that we originally started with. So, should we always use counter caches? It depends, of course. Counter caches are kind of primitive. They don't really offer a ton of options. If you wanted to load any single attribute, even if you were just looking for maybe the name of every single commenter or the timestamp that every single commenter left their comment, counter caches is going to be able to help you there. And on top of that, counter caches don't really deal with edge cases all that well, so if you wanted to build a condition into your count, it's a little hard to build that in. It's possible, but it's not really working with you. You kind of have to muscle your way into it. Another thing that you have to think about is all of those update queries. So if you have a read-heavy application, like most applications are, it's not really going to be a big deal because you're probably going to be creating comments way less frequently than you're going to be reading the number of comments. But if you have a write-heavy application, that could potentially be an issue. Those update queries are really fast, but if you're doing them all the time, it might still be a bottleneck. So that's just something to watch out for. And I actually want to zoom out even a little bit more and ask, well, are n+1 queries always bad? Because we kind of started this discussion on the assumption that we're trying to remove them all the time. And I was pretty surprised to find that the answer to this is also, it depends. So there was an interview between DHH and Nate Berkopek, who literally wrote a book on performance in Rails applications, and DHH says about n+1 queries, they sound like a bug, but in a Russian doll caching setup, it's not a bug, it's a feature. The beauty of those individual calls are that they're individually cached on their own timeline and that they're super simple. So this was really new to me. As someone who doesn't really work with Rails in a full stack capacity, I tend to use Rails more to build APIs. I didn't really know what Russian doll caching was, and I didn't understand what he was getting at, the reasoning that he thought n+1 queries could potentially be a good thing. So I looked into it, and Russian doll caching, the name comes from these Russian dolls. So it's actually a form of fragment caching. And fragment caching in Rails is when you cache a piece of view logic. So if you wanted to build a full page and that was composed of a bunch of little pieces, so if you have like a menu bar or something like that, you could cache each of those fragments, and instead of rebuilding the whole page, you would just pull those fragments in. Russian doll caching is a particular type of fragment caching. It's essentially nested cache fragments. So if you had one fragment that was fairly large and it was composed of multiple smaller fragments, and one of the smaller fragments was invalidated, then instead of rebuilding the entire large fragment, only that one small, how many times have I said fragment? Only that one small fragment needs to be regenerated. So here's what it looks like if we turn the cache on. And I'm not doing anything special in the controller here again. I'm just calling post.all. So on a cold cache, this is the log that we're going to see. It's pretty expected, I guess. This is a fresh load, nothing's in there yet, so we're going to see those n+1 queries executed, and it is probably going to take a while. And because we're turning the cache on now, surrounding every single one of these queries is going to be a read and a write. Because we're going to try to read that fragment, and all of them are going to result in misses, since we haven't warmed up this cache yet. But right after we execute the query, we're going to write the fragment that we just generated into the cache. So now as we reload the page, our cache is warmed up. What does the query look like now? With all of those fragments loaded in cache, we're actually just going to go and directly pull all of the fragments. We're just going to read those fragments, and notice there's no misses, there's no writes, there's no queries even. So we're not interacting with the database at all. And the only query that we run is that first post query. It's just one simple query. So it's actually better than any of the solutions we've discussed so far, really. And that's not even the best part. So the point of this nested cache fragment is if we were to go and update one of those comments, so one of the inner associations, it's going to really, you'll see what happens in the logs actually. If we've set up Russian doll caching properly, which is basically to say that we're going to cascade the touch, so we're going to make sure that updating a comment gets cascaded to the owner object, so the post, then the log is going to look like this. We're going to read a bunch of valid fragments. Those are all of the posts that haven't been updated whatsoever. And then on one post object, it's going to recognize that the read resulted in a miss. And that miss is going to be because that post has been updated, because a comment belonging to that post has been updated. So for that one particular fragment, we're going to go and fetch the comments associated to that post, and then write that fragment again, and then it'll just continue on with a bunch of reads. So now instead of one simple query, we're executing two really simple queries. The first is for posts. We always need to run that query to make sure that we're looking at the right IDs and we know when they were last updated. And the second is for the comments that were dirtied, that were updated. That's really great. Okay, so what if we use includes? Because remember, I haven't done anything special in the controller just now. If we use includes, it's going to behave the way that we expect. It's going to put those two queries in. So the first is going to load all of the posts, and the second is going to load all of the comments associated to those posts. And then it's going to read a bunch of fragments. So because this cache is warmed up, we're not actually going to use any of the comments that we just loaded from the database. That was actually a waste of time. So if we have the right caching strategy, then we're just going to pull straight from the cache. We don't need that second query. We don't need to use includes whatsoever. So later on, DHH says the whole way you get around doing n+1 queries is by using joins. You do more complicated queries that take longer to compute and tax the database harder. If you can simplify those queries, but there's just more of them, well, you win if you have a caching strategy to support that. So even though it's not purely necessary to execute n+1 queries just to get all the posts and the comments associated to each post, if you have a caching strategy that supports it, if you've built your system to support it, then n+1 can actually be your friend. You can use it to increase the performance of your application. And that is the power of lazy. So some people say that ActiveRecord should eagerly load queries, or at least eagerly load them in the sense that they should be loaded by the controller layer instead of postponing all the way to the view layer. But if you set up this type of caching strategy, then you're going to be writing a lot of queries in your controllers that you expect to never run. So that post.all query, we don't really care about the associated comments because we're expecting a cache to be warmed up. We're expecting the cache to be sitting there. And even if we have a fresh page load, that just means that we have one slow page load one time. That's something we can probably handle. All of these queries in your controllers that aren't being executed, well, that's great because they're only going to be executed when necessary. When necessary. Only when something is invalid or some special condition has been met. So since I usually use Rails in an API form, the next question I asked was, well, how do I set up Russian doll caching in APIs? Because I saw a lot of resources on how to do this with the rest of Rails, so with Rails views, but very few on APIs. And this is where my talk actually overlaps a little bit with what you heard this morning. The things that I did run into were Active Model Serializer and JBuilder. But I didn't have a lot of hope. There wasn't a ton of discussion around it, especially around Russian doll caching. It seems like both of them have some sort of caching mechanism, but sometimes the caching is actually slower than just reserializing the object or reconverting the object into JSON, so why would you bother with caching in that instance, right? And of course, like we heard this morning, in February of 2018, the Netflix tech team actually released a gem. And I think this is really awesome because in general, I think it's really awesome when your team works on cool stuff and you open source it to share with the rest of the community. So this gem is called FastJSON API, and again, like we heard, they promise a serialization time at least 25 times faster than Active Model's serializer. But I didn't see a lot of instructions on how to set this up with a Russian doll, so I played around with it a little bit in my demo app, and it seemed like things were working. But I would love it if you would experiment with this and give me a little bit more confidence around this, because my demo app, it has 10,000 objects, but it's still 10,000. It's not, it's not huge. So I think you can get this Russian doll set up if you set your cache keys correctly. This is what my serializer looks like. It's not really that complex. If you take a look at the documentation for FastJSON API, this is a pretty generic serializer. The only special part is that along with my post, I'm going to be caching the associated model, which is the comments. So on a cold cache, like we expect, we're going to get n+1 queries. It's going to take a little bit of time. And on a warm cache, it's not really going to take much time at all. It's only going to execute that one query for posts. But this is still behaving in a pretty typical cache manner, so I wasn't very confident at this point whether Russian doll caching was going to work. So I went and did that test. I updated one of the comments, and it seemed to work. I'm only getting that one query for posts, and then I'm getting a second query for the comments on the post object that I've updated. That's a good sign. That means that maybe we don't have to use, specifically Russian doll caching to get this type of behavior. We can get nested cache fragments, or I guess they're not fragments since they're not views. We can get nested cache in other ways. So I'm really looking forward to playing around with this a little bit more and exploring it. Now, should we always use caching? And of course, if you've seen the pattern to these questions, the answer is, it depends. Sometimes, for whatever reason, your application just can't handle cache. Maybe you're really, really concerned about accuracy, or maybe you just have reasons. I don't know. Or, you probably know this pretty famous quote, there are only two hard things in computer science, cache invalidation and naming things. So if you do take on this caching strategy, then instead of your headache being n+1 queries, you have a headache around cache invalidation. So you're really just trading your problems in for more problems. Okay, so in this presentation, we've kind of explored 3 ways to resolve these n+1 queries. The first was kind of includes, touching on preloads and eager loads. The second was this counter cache, and the third was Russian doll caching or nested caching in general in APIs. And I'm not saying that one of these is better than the rest. Rather, it's pretty important, or it's really helpful to know all 3 of them, so that in your particular use case, you can really easily identify which of these is best for your problem, best for your performance issue. And if you take nothing else away from this talk, I hope what you remember is that the answer is almost always it depends. There is never one right solution. Especially around performance issues, you always want to rely on your profiling and benchmarking tools, and that will tell you which of these solutions is going to be best. So that's pretty much all I have. This is where I'm going to post the demo, but don't go there yet because it's not ready. If you visit on Sunday, it'll probably be up there. Yeah, so I'll be around if you want to chat about eager loading or how I flew to this country illegally.